All right, and we were just finishing up part B, writing each number in trig form. So here is the first and the second complex number written in trig form. Part C then asks us to find the product in trig form. Finding the product in trig form, we're going to take each of these and multiply them together. So z1 times z2. We're going to take the two radiuses and multiply them, 2 times 8. And then remember the rule is to add the angles. So 2 pi over 3 plus 11 pi over 6. To add these two together, we need a common denominator. So we can multiply this by 2 over 2 and think about getting 4 pi over 6 plus 11 pi over 6. And that would give us 15 pi over 6. Bringing down the rest of the problem, we've got 16 cis 15 pi over 6. We usually want to write this angle in between 0 and 2 pi. We can think about reducing each of these as divisible by 3, so that would give us 5 pi over 2, which is coterminal with pi over 2. So here's our product in trig form. The last part is asking us to change trig form to standard form. So if we take this answer in trig form and change it to standard form, part D, that would become cosine of pi over 2 plus I sine of pi over 2. Well, if we think about where the angle pi over 2 is, cosine is the x value, that's 0. And the value of sine, the y value of pi over 2 is 1. So 0 plus I times 1 is I, 16 times I is 16I. So we can see that our answers from way back here in part A and the answer to part D are exactly the same. The last topic that we're going to cover in this section today are powers of complex numbers. Let's first examine taking a complex number in trig form and raising it to the second power. So we can think about raising this entire side to the second power. Well, this is a product, so we can raise r to the second power, and we can raise this binomial, cosine theta plus I sine theta, also to the second power. Well, squaring this, we're squaring a binomial, so we're going to have to think about using FOIL. That would be cosine theta plus I sine theta times itself, times cosine theta plus I sine theta. And if we use FOIL to distribute all of that, we've got cosine squared. The outer is plus I cosine theta sine theta. And the inner is the same, plus I times cosine theta times sine theta. And the last would be plus I squared sine squared theta. Cleaning this up a little bit, we can combine these two and factor out the I. We can also think about I squared becoming a -1. So I'm going to write cosine squared minus sine squared. So I've used up this term and this term. And I'm going to factor out the I, and we have cosine times sine plus another cosine times sine. Since these are the same term, we can combine them. Cosine squared minus sine squared, that is a double angle formula for cosine. So we can rewrite that as 2, or sorry, not 2 cosine. This is the cosine of 2 theta. And cosine of theta times sine theta plus cosine sine, again, we can write that as 2 cosine theta sine theta. And you should recognize this as a double angle formula for sine. So 2 cosine theta sine theta is the same as a double angle formula for sine, which is sine of 2 theta. If we were were to continue this process to the third power or to the fourth power, we see a pattern that emerges. And what happened here with squaring is the same thing that's going to happen if we raise it to the third or the fourth power. The radius is going to take on that power, and the angle within the function will be multiplied by that power. That leads us to de Moivre's theorem. De Moivre's theorem says if we have a if we have a complex number written in trig form, and n is a positive integer, then taking that complex number and raising it to any power, the same thing happens that we found in this example. We take the radius and raise it to the nth power, and we multiply the angle by that power. Here's the simplified version. For example, if we want to evaluate 1 minus root 3i to the 8th power, the algebraic way or the long way would be to multiply those binomials out with 8 factors. That would take a really long time. The easier way is to put it in trig form first. So first let's think about trig form. I'm going to think about graphing 1 and negative root 3i. So positive 1 and negative root 3i is down here. That angle would be 1, 2, 3, 4, 5 pi over 3. You could also find that out by doing the tangent of what angle equals b over a, negative root 3 over 1. And it's going to give you the same angle. We also need to find the radius. R equals the square root of 1 squared plus negative root 3 squared. So this 1 plus 3, root 4, we get 2 for the radius. So we can write 2 cis 5 pi over 3. This is the same complex number in trig form. And we want to raise it to the 8th power. So raising this complex number to the 8th power, we can apply de Moivre's theorem. Take the radius and raise it to the power, and you take the angle and multiply it by that number. So we're going to do 8 times 5 pi over 3. And now we can just simplify each one of these. 2 to the 8th power, off the top of my head, I'm not 100% sure. Let me get my calculator out. 256